Well, good morning, everyone, and thank you for coming to the Cloud Robotics Summit and coming to this particular session. Today, we are going to talk about simplifying simulation worlds creation for Gazebo. My name is Ray. I'm a product manager from the AWS RoboMaker team, and today, co-presenting with me is Sam Gundry. Sam is a simulation engineer from the AWS RoboMaker team. And here's a brief agenda for today's session. I will be giving an introduction about simulation and AWS RoboMaker. Then we'll be introducing a new capability in AWS RoboMaker called WorldForge. Then Sam will give you guys a deep dive and also a walkthrough of this new RoboMaker WorldForge capability. And then that's the fun part. Sam will help you guys understand some of the technical challenges we faced during the development of the WorldForge capability and how we solve these problems. And of course, in the end, we will have some time for questions. So before we get started, a very simple question: what is simulation? Because simulation is a fairly generic term, and simulation as a technology has been used very diversely in different industry segments and for different use cases. Here's a definition that I found to be very accurate that I like a lot, and it says simulation is an attempt to model a real-life or hypothetical situation on a computer so that it can be executed to see how the system works. By changing variables in the simulation, predictions may be made about the behavior of the system. It is a tool to virtually investigate the behavior of the system under execution. And for AWS RoboMaker, the type of simulation that we focus on is robotic simulation. And by the very definition, and that means here the system under execution here is a robot or a piece of the software that's running on a robot. So what are our customers using simulations for in the space of robotics? Number one, testing. We've had a lot of customers using simulation to test the functionality of their physical robots inside a virtual environments. We've also had customers doing machine learning model training using the simulated environments. And also synthetic data generation is from the simulation, you can capture pre-labeled synthetic data and typically these imagery data, and then you can use these data to solve problems such as computer vision. You might be asking that, I can do all of these things in the real world on a physical robot. Why do I want to do that using the simulation? Well, for testing, because it's more robust, you can design and have a large variance in the environment, and so that it can cover a lot more test cases than you can in the physical and real world. And that way, you will have much more robust testing of your robotic functions using the simulation. For machine learning model training, because it's faster, not only that inside the simulation, you can run faster than real time, but at the same time, you can use multiple simulations running in concurrently to train the same machine learning model. So that way you have a much faster iteration time as you train the model. For synthetic data generation, it's much more cost effective, not only from the simulation that you can have a lot of environmental variance to give you a very rich data set, but at the same time, because you generate a lot of these images using a simulated software, if you do the math and figure out a cost per data set, it's much, much cheaper to do that in simulation versus hiring somebody to take these images in the real world. Now, some of you might have noticed that there is a consistent pattern across using simulation for these different use cases. And that is, you get the most value out of simulation by doing these type of use cases when you run a lot of these simulations. You get much more robust testing because you're covering a lot of different testing scenarios and cases when you run a lot of simulations. You have much faster iteration and training speed when you have many, many simulations to train the same machine learning model concurrently. And your cost per image is much, much lower as you run a lot of simulations and generate a lot of synthetic data set from the simulations. So in the end, I think it's all about scale. That's when you get the most value out of simulation when you run simulations at scale. So that's simulation, but what is RoboMaker Simulation? RoboMaker Simulation is a capability that we first announced at the end of 2018 during the reInvent conference. And RoboMaker Simulation is a fully managed infrastructure for running robotic simulations. First, as mentioned, it's all about scale. RoboMaker Simulation is highly scalable. You can run tens, hundreds of simulations using a single API call without worrying about any infrastructure behind the scene, and RoboMaker Simulation will take care of these management for you. Next, RoboMaker Simulation is a fully managed capability so that you do not need to worry about any software setup or configuration because we've got everything pre-configured and pre-installed behind the scene for you. Last but still very important, RoboMaker Simulation is cost effective. You really pay for what you use. And not only that, we charge at a granularity of per CPU and per minute. So you only pay for the resource and the amount of time that you run simulations on RoboMaker Simulation. And since we launched RoboMaker Simulation, we have customers across the robotics industry segment using RoboMaker Simulation to run different use cases for their company. And they've got great value out of running simulation for robotics and running simulations on RoboMaker Simulation capability. But that's not what we're here really to talk about today. So next, I want to come back to from the very beginning when we introduced the definition of a simulation. So if I were to translate that very definition into a graph, this is kind of how it looks like. You first have to model the robot and model the environment, which we typically call a simulation world. Then once you've modeled your robot and simulation world, you feed these as inputs into a simulator, and that's running on some compute infrastructure, for example, like the highly scalable and reliable RoboMaker simulation infrastructure. Then, depending on the type of use cases you're using simulations for, if you are doing testing, the simulator will output testing data. You can then analyze, debug, troubleshooting. If you're doing machine learning model training, then the simulator will output training data. These data will then get fed into your machine learning model for training. And again, if you're doing synthetic data generation, then you will be generate these pre-labeled synthetic image data out of the simulation, and then you can use these data to train your computer vision algorithms, for example. So the very first sentence in this simulation definition, as it says, you need to model a real life or hypothetical situation. And that is what I'm highlighting here, which is the simulation world, the virtual environments where you are simulating your robots or your robot functionalities. That's the very basic ingredient for you to get started with simulation. And then the second sentence, which is very much consistent with the scale that I mentioned about simulation, you do that by changing the variables. You do that by running simulations in a lot of variant simulation worlds so that you get the most value out of the simulation. No matter whether you're doing testing, you're doing machine learning model training, or you're generating synthetic data sets. And that means you don't just need one simulation world. For you to effectively run simulations and get values out of it, you need a lot of simulation worlds to start with. But there are some problems with simulation worlds. First of all, creating a simulation world is very hard. It requires specialized skill sets such as 3D modeling, and you also need to know the specific engines that you're running the simulations on. And when you need to create a large amount of simulation worlds, it's just n times harder. Next, creating a simulation world is time-consuming. It often takes weeks and sometimes even months to create a single simulation world. And you can do the math when you need to create n simulation worlds that could take months or even years. And third, creating a simulation world is very costly. It costs thousands and sometimes tens or even hundreds of thousands of dollars to create a single simulation world. And again, if you need to create a large amount of simulation worlds, that'll cost a fortune. And that is why at AWS RoboMaker, we built this new capability called RoboMaker WorldForge. WorldForge is a new RoboMaker capability that automatically generates one or more residential simulation worlds within minutes. WorldForge provides out-of-the-box 3D assets, such as tables, chairs, and beds, so that you don't need to spend any time or money building these assets. WorldForge also provides these pre-built templates so that you can generate a large variety of different type of residential homes without doing any additional configuration. You can just choose from one of these templates we provide. Next, WorldForge can generate a simulation world within minutes as compared to weeks or months when you do that manually. And for each of the generated world inside of WorldForge, you only pay for $1.50 as opposed to thousands or tens of thousands of dollars if you hire an artist or a simulation engineer to build these simulation world manually. And as I mentioned, scale, scale, scale. Simulations are all about scale. WorldForge, you can generate many different worlds concurrently, and we'll take care of these concurrent generations behind the scenes, which Sam will tell you guys a little bit more about the details later on. And finally, WorldForge is integrated with the RoboMaker simulation capability. So after you generate these simulation worlds inside WorldForge, you can easily go to RoboMaker Simulation, bring your robot code, and then start running simulations using these worlds. Okay, that's my part. And then next, I will be handed over to Sam. Sam's going to give you guys a deep dive and a walkthrough of the WorldForge capability. Sam, hand it over to you.
Thanks, Ray. Hi, I'm Sam Gundry, an engineer with RoboMaker. Today, we're going to do a deep dive and a demo of WorldForge. Afterwards, we'll look at WorldForge under the hood, how it's being implemented. AWS RoboMaker WorldForge is based on templates. The templates are JSON. We have an interactive template editor in the AWS console. You can use the console to create and customize your worlds and then easily generate tens and hundreds of worlds. It's integrated first class with AWS RoboMaker Simulation, and the worlds are fully physical. Today, I'll walk you through a demo of editing templates, generating worlds, running in RoboMaker Simulation. Let's get started. So here we are. Here's the AWS RoboMaker WorldForge console. We're going to create a template and then generate worlds. Out of the box, WorldForge provides 4 sample templates. We're going to use those to create worlds in our first demo, and then we'll come back and go into detail. You can also start from scratch. Here we are. We're going to select the living and dining room sample template. It's 2 rooms. We click Start, and that puts us into the World Template Editor. This is where we will edit interactively, customize our worlds. But first, let's generate some worlds. Okay, so first, we can just request one world to start with. This will create a generation job. The WorldForge is now generating your 3D physical simulation world. In a few moments, we'll speed ahead and you can see the world will complete. And there it is. It's our first world for the day. We can click through to the world detail page. Note it has 2 rooms. It has the living room and dining room that we asked for in our template, but it looks different to the sample template image. The layout looks a little bit different. The meshes in the floors, the textures in the floors and the walls look different. And the furniture has the same types, but you can see here they're laid out differently. And this is the real power and magic of WorldForge. From that one template, in as few as 4 clicks, we can generate a fully 3D world for simulation. Okay, now let's go back to the world template editor. We're going to customize our world today. We click through and jump into the editor. As you can see, the editor has 2 parts to the view. We can see the rooms in the cards on the top and then the fields on the bottom for editing. We can also name our template. We're going to name these templates so our QA engineers can easily come back and look for templates to generate more worlds. We're going to add 4 more rooms to this to make it a 6-room house. The floor plan has dimensions. Now the dimensions can control the aspect, the shape of a floor plan. Now it's a desired aspect ratio because it's not guaranteed, it's a preference. You're giving a preference to WorldForge to use that to give guidance to the shape of the world. Now, instead of square, we're going to make it wide, so a 3:1 ratio, and we set the ceiling height to 2.4 meters. Now we can start adding our rooms. Here's our rooms list. We can view the cards on top, and we can also edit rooms. The desired area is similar to the desired aspect ratio. For a room, it's a guidance, a suggestion. We'll randomly generate worlds close to your desired area. So we create a bigger living room, 45 square meters, and a wider living room. Next, we'll start adding some rooms. We can name our rooms for referencing later in Gazebo and in the template. We're adding a bedroom. We choose the bedroom type, we specify its desired area and its desired aspect ratio. Next, we'll add a bathroom. WorldForge provides 7 room types. These room types affect where they are in the floor plan layout, and later, as you will see, in what materials are assigned and what furniture is populated. Next, we're adding a kitchen. We'll make that larger, and we'll make that a little bit wider. So as you can see, we're building up this floor plan from 2 rooms out of the box sample template to adding 4 custom rooms. We're going to create a hallway and we're going to use the maximum aspect ratio, so it's long and narrow. And there you have. There are 6 rooms, the list of rooms is there, but now we want to actually have some custom on where they are laid out in the world. So this is what connections are for. Connections give us a preference for a room adjacent to another room. There are 2 types of connections. There's an opening and a doorway. I'll show you both now. The first connection we're using is an opening. An opening means 2 rooms will be adjacent, but there will be no wall. They'll share a space like an open plan. So in our template, we're asking WorldForge to put the dining room next to the kitchen without a wall. Next, we're asking for a doorway between the living room and bedroom. A doorway means there will be a wall, there's a shared wall, with a gap the width of a door. Similarly, we're going to add a doorway between the living room and bathroom. And there you have it. We've got a 6-room floor plan. It's updated in the top. You can see the living room's connected to the bedroom and the bathroom via a doorway. You can see the dining room. It has an opening through to the kitchen. So that's the floor plan, that's the layout. Next, we're going to look at decorating the interior. So you can decorate the interior via different materials on the floor and the walls. You can also add furniture types. Out of the box, we'll do this for you. By default, we'll assign random types based on random materials and random furniture based on the room types. However, we can also override these and customize. We may want to do this to test the robot physics or test the robot's object detection. In this example, I'm going to add wood floors to some rooms. You can add floors and materials to room types or by room names. You can see here, any dining room, any hallway, any kitchen and living room are going to get our wood floors. We're assigning parquetry and floorboards. You can see the thumbnails there. Out of the box, WorldForge provides flooring materials and wall materials. Now we're going to add some custom walls. Just like floors, we can override their materials. Instead of doing it by room type, I'm going to assign it to a particular room. We're going to add wallpaper and brick walls to our bedroom and to our kitchen. We're selecting those rooms by name, and then we add some custom materials. Similar to the floor, here are some materials for walls that are specific for walls, and there's the thumbnails. You can see the bricks and the wallpaper. And now we're going to add some custom furniture. We can specify an empty room or override custom furniture in any one room. We might do this because we want to test the robot in a challenging situation. Today, we're going to test the robot in a hallway with just storage benches and buffets. For instance, our robot may not be able to navigate between the buffet legs, or it may not be able to detect the storage benches. So here we go. We are choosing our furniture based on type. Out of the box, WorldForge provides hundreds of assets. We're going to choose sideboards and buffets, and there are the thumbnails. There are some of the samples that you will get when you generate a random world. And now we're going to choose these benches, the storage benches. Yep, there it is. And as you can see, we have some benches. And that's it. We've gone from a 2-room sample template to a 6-room house. We've overridden the flooring and the wall materials, and we've added some custom furniture. This template can now be used to generate any number of worlds you want. The card views have been updated. We can quickly inspect. The hallway, as I said, has sideboards and buffets. The kitchen has wallpaper and bricks. And now we can generate worlds. And this is really powerful, this moment. We are taking a template and we're generating up to 50 worlds in one request. Now, we can ask for a number of floor plans. So if we ask for 5 floor plans, we can then ask for a different world per floor plan. For instance, we're going to ask for 5 and then 3 interiors per floor plan. What this means is for every floor plan, we'll get 3 different worlds. So a total of 15 worlds. And we're going to generate these worlds now. We've submitted the request to WorldForge, and now we have a generation job. The jobs page will stream worlds in as they complete. Once a world completes, you can then use this for simulation. Jumping forward time a little bit, and the first 5 worlds are completed. As you can see, there are several different floor plans. The world, the dimensions, is now long and elongated according to our template parameters. The hallway in the center there has only storage benches and buffets like we requested. And this is the power of templates. You can specify preferences, but we will randomly generate worlds according to those preferences. Fast forwarding time a little bit more, and we'll see the next few worlds come in. Yep, 5 more worlds, again, different floor plans. And when the job completes, we'll have 5 different floor plans, each of those with 3 different interiors. Jumping forward a little bit more, and there we go, the job's complete. We've got 15 worlds. After clicking through, easily creating a template, and in a matter of tens of minutes, we have new worlds. You can search and filter worlds, and you can label worlds via tags, so your QA engineer can easily search for worlds for their specific scenarios. You can jump into a world details and view its large preview and have a better inspection. As you can see, this is another world where the hallway has just benches and buffets and a different floor plan layout. So this is powerful, but even more powerful, you can create different templates for a more diverse, more set of worlds. We're going to go through and generate worlds for each of our sample templates. First, we're going to select the single room template. It's a bedroom. Out of the box, we can click through, generate worlds without any changes. We're going to ask for 2 floor plans, so that's a single room. The room might be a different shape, a different size. Next, we're going to use the living room and dining room template and generate 2 more worlds. As we're doing this, we're creating these templates in our account that we can come back to and regenerate later. Next, we're going to use the apartment sample template. It's a 4-room, open plan house. And again, we're going to generate 2 more worlds. Lastly, we'll use the 4th template. It's a small house. It has 6 rooms. It's a larger space. And we'll just generate 1 world for this. Now we're doing this because we can see the variety of templates in just a matter of a few clicks. The jobs are all running. The 4 generation jobs were requested, and you'll see the worlds speeding up time a little bit. You see the worlds complete. We have 4 completed. We'll see another 2 complete, and then finally we'll get 7 worlds completed. And there it is. We have 7 new worlds. This is our worlds page, and you can see the different floor plans, the 2 different bedrooms, the beds in a different place, and all the other sample templates have easily generated all these worlds. There's a huge amount of variety to test your robots, test and train your robots. So next, we've got all these worlds, but really we're doing this so we can simulate. And RoboMaker WorldForge is integrated first class with RoboMaker Simulation. We're creating a new simulation job for Ross Melodic. We support all the software that RoboMaker Simulation supports. We're going to skip a robot application for the demo, and we're going to use the Hello World GitHub sample application. It has been updated to support WorldForge worlds out of the box. I couldn't resist creating a new simulation application, and it's Hello WorldForge. As I mentioned, the software suites are all supported, and the launch file we have a new launch file in the GitHub repository that'll let you load worlds out of the box. And now we select which world to create the simulation job with. We browse, and we can select with a preview thumbnail. This lets you confirm the world you want to load before creating the job. These are, as you can tell, these are the worlds we created just before. There's the single bedroom, and now we're going to choose one of the 2 room houses. And that's it. In a matter of clicks, full integration, you can create a job. RoboMaker will import your world into a simulation environment. Jumping forward a little bit, here's the job that started. We're opening the Gazebo client GUI tool, and there's the world. There's our house, the 2 rooms. As you can see, WorldForge's assets have been loaded. There's the floorboards, there's the wallpaper, and there's a robot in the dining room. WorldForge guarantees that the default position in Gazebo 000 is always clear. That means you can start your robot in any simulation world without worrying about colliding with furniture. We're going to show you the robot's point of view now. This is the camera on the robot running. It's on the camera topic, and this is via Ross. As you can see, the robot can see the floorboards, it can see the assets. We're going to steer the robot through the world. This demonstrates the physics of Gazebo and the physics of WorldForge. We're driving along the floorboards. We can collide with any of those assets. And we can challenge our robot. We can test and train our robot in all these random different environments. Next, I'll show you what this looks like to the physics. In Gazebo, we're going to enable the collision meshes. These are the orange renders. This is what the physics engine sees when it collides different objects. This is the mesh of the collision objects. You can see the TurtleBot, the robot, has a high fidelity mesh, so do our assets. You can see the orange mesh in our world provided by WorldForge. And there you go. There, in a matter of few clicks, we've created 20 to 25 worlds. We've imported those into simulation, and we have a physical simulator running with our robot. Next, I'll show you how you can export a world so you can run with it locally. We create an export job, we choose our world. This will upload a .zip file into your S3 bucket. The .zip file is a ROS workspace. It's compatible with ROS 1 and ROS 2. You can download this .zip file into your workspace and then continue and running simulations locally. For instance, here I've downloaded the zip file into the Hello World GitHub sample application, and it has its gazebo.world file. It has a nested model, so you can use the WorldForge world in your own .worlds. And here are the assets, the models, the furniture models. You can then build and run locally with ROS Launch. It's as easy as that. And there you go. There's one of the worlds we generated earlier in Gazebo. Okay, so we've seen a demo of WorldForge. We've generated 20 to 25 worlds. We've edited the template. We've imported those into RoboMaker Simulation. A few clicks. Now let's look under the hood. Today, I'm going to talk you through some of the core implementations of WorldForge. It is a serverless parallel random world generator. What does that mean? We sit on AWS function workflows. We can scale by independent generators, and I'll explain what a generator is after this. And the algorithms are probabilistic. Probabilistic because we're able to create random worlds. Procedurally create these according to your template inputs while retaining realism. And lastly, I'll talk a bit about where the assets come from. You saw the orange meshes in the Gazebo demonstration. I'll explain how we process these. First, AWS step functions allows us for dynamic parallelism. As you can see, the diagram on your right, we have a flow. It's a workflow is a chain of dependencies. We're using map and parallel states to scale out our generation. You saw in the demo where we requested 5 floor plans and 3 interiors, and this is how it works. The request for 5 floor plans comes in at the top. We then generate each floor plan independently. For each floor plan, we then populate the world. So we came in with 5 floor plans, each of those spans out to 3, and then we have 15 worlds being generated. Our generators are independent. They can be executed in parallel. So for instance, we're furnishing a bedroom. That bedroom doesn't need to know about the bathroom. We can execute these independently. And that gives us another level of parallelism. For every world, for every room, we can populate it with furniture. So using this workflow, using AWS step functions, we can control for concurrency and scalability. Moreover, we can easily add new generators. Now, I've touched on what a generator is. It's obviously generating a floor plan. We're also calling a room furnisher a generator, but we can also add new generators without affecting existing ones. And importantly, we minimize input-output. So in a 3D world, there can be a lot of binary data, but this does not have to be shared. When the floor plan's generated, it generates a text description to pass down the workflow. Similarly, when we furnish a room, the room doesn't need those meshes that you saw in Gazebo. It doesn't need the orange mesh. It doesn't need the textures or the images. It just needs a description of the data. And I'll go into what that description is in a second. And here is our first generator. The floor plan generation solves for optimizations. What is an optimization? An optimization is an evaluation of a solution. We need candidate solutions to then evaluate how good they are. To come up with candidate solutions, we need the ability to change a floor plan. We can change a floor plan by splitting walls, by moving walls, by swapping rooms, by adding rooms, and by disconnecting and reconnecting. Once we change a floor plan, we can then score it based on your template parameters. So you saw in the demo how we specified a larger dimension of aspect ratio for the layout. We created larger rooms. Those all contribute to the score, just how close we are. Interestingly though, we don't want to be exact. We want to have some randomness, and that creates the magic of WorldForge because you can get so many random worlds. So it's a fine balance. We use procedural generation. with some randomness to create that diverse floor plans. So we have the workflow using AWS step functions. We fan out, generating independent floor plans, and then that goes through to the room furniture. Room furniture is another generator. We need to populate each room with our assets. Room furnishing is two parts. It's selecting the furniture type and then placing it in the room. Furniture object selection is random and it's based on room type or, as you saw, on template inputs. So in the demo, we overrode the hallway to choose only storage benches and buffets. WorldForge has an asset catalog that we can randomly choose from. Then, once we've made our selection, room furnishing needs to choose where to put it. And this is based on rule heuristics. As I mentioned earlier, furniture objects have metadata. They have properties that describe them semantically. So they have bounds. So you can imagine a dining chair has a cube around it where its extents are. It has a category, a dining chair, a dining table, a bed. It also has an orientation. The back of a bookshelf is important compared to the front of a bookshelf. We may put the backs against walls and the fronts need to be accessible. And that brings us to the next metadata. Where are the objects accessible? So to access a bookshelf, we need to know the front. To access a fridge, we need to know the front. The dining table, we want to access all four sides. And then there's relationships. A dining table generally wants dining chairs, probabilistically. A bed may have a side table or a floor lamp. So there we have it. There's room furniture. We select and place based on rule heuristics, and we guarantee accessibility by paths from every door or from each door to every object. So as you saw before, we've got the AWS step functions workflow. It fans out, generating floor plans for every floor plan, for every room in every floor plan. We then populate it with furniture. But where do these assets come from? And that brings us to the next under the hood stage. You saw in Gazebo, we had assets with a orange mesh. And this is part of our pipeline for processing furniture models. When you're in simulation, you saw that it requires physical properties. The floor has a friction, the furniture objects have a collision mesh. Our source assets contain high fidelity visual data. We need to figure out their physical properties. We derive these automatically. However, not all simulations require high fidelity physics or high fidelity visuals. We want that level of control. So our automated processing pipelines has a control for the level of accuracy for the meshes. So on your right, you can see the green collision mesh that we've automatically generated. The far right is less tight than the far left. In the bottom right picture, you can see the high quality visual objects in a render. So together, the parallelism of workflows, the fan out of the floor plans, the independence of the generators, together with this asset catalog, creates a magical experience. We can create tens and hundreds of random worlds so you can better test and train your robots. And that brings us to a close. Thanks to Ray for introducing WorldForge. Thank you all for watching the demo and having a sneak peek under the hood. And remember the problems Ray discussed. Creating a simulation was hard, it's now much easier. Creating a simulation world was time consuming, it's now much faster. Creating a simulation world was costly, it's now much cheaper with WorldForge. So, go generate simulation worlds. Thank you very much.